In fact, the most volcanically active place in the solar system is Io.
Within the realm of the gas giants, there exists a mysterious world veiled by dense layers of haze. Titan, a moon larger than Mercury, orbits the ringed planet Saturn and has intrigued scientists for years. Beneath its obscuring clouds, vast seas, lakes, and rivers flow across a frozen landscape. Titan stands as the sole location in our solar system, aside from Earth, where liquid exists on the surface. In today's episode, we will answer, could life possibly thrive within Titan's seas and lakes? And if so, what might it resemble? This is Reveal the Mystery. If you are curious to learn mysteries of the world, space and beyond, consider subscribing. Traditionally, scientists believed that all celestial bodies in our solar system's moons were similar to our own moon, inactive and composed mainly of lifeless rock. In the early 1970s, NASA's Pioneer 10 and Pioneer 11 spacecraft explored Jupiter's moon Io, revealing that its mass was unexpectedly large and its composition differed from the norm, making it the densest moon in our solar system. Io's thin atmosphere intrigued scientists, but radiation belts hindered in-depth investigation. In 1979, Voyager probes with advanced equipment provided high-quality images of Io's surface, showing a lack of impact craters. Initially, NASA thought Jupiter's gravity was deflecting meteorites, but they discovered evidence of volcanic activity driven by Jupiter's gravitational forces, which heated Io's interior, causing silicate magma mixed with sulfur to erupt. This sulfur created a toxic, radiation-enhanced environment on the surface. However, beneath Io's surface, lava tubes offered potential habitats for microorganisms, similar to sulfate-reducing bacteria on Earth. To colonize Io, humans would need to emulate these bacteria, living underground to avoid volcanic eruptions and radiation. While underground bases could provide some protection, complete immunity from radiation and electronic malfunctions would remain a challenge. Triton, one of Neptune's moons, showcases active volcanism and was extensively studied during Voyager 2's flyby in 1989. Contrary to expectations, it revealed a complex landscape with mysterious dark geysers erupting at a frigid minus 235 degrees Celsius due to cryovolcanism. The knowledge about underground water reservoirs causing these geysers is limited. To establish a base on Triton, insulation, not just radiation protection, would be crucial, possibly utilizing local ice blocks and extracting water and energy resources. Nonetheless, the main obstacle to colonizing Triton is its immense distance from the Sun, making a 12-year journey unattainable with current technology. Even NASA's Triton exploration missions face delays. Shifting focus to Jupiter's moons, particularly Europa, Galileo's 1995 mission unveiled cracks in its icy surface, indicating a vast subsurface ocean. The exact composition of this water remains unknown, and reaching it necessitates drilling 150 kilometers through the ice or capturing expelled water molecules from surface cracks for analysis. Astrobiologists speculate that Europa's environment might host organisms resembling adaptable Earth bacteria. Colonizing Europa would be challenging due to harsh conditions. An option is constructing an underwater base, extracting oxygen from water, and using specialized drones for icy surface exploration. The surface's high radiation levels pose a significant challenge. If underwater bases or other solutions prove unfeasible, exploring other Jupiter moons might become a more practical alternative. Ganymede, a moon of Jupiter, stands out as an exceptional celestial body in our solar system due to its minimal surface radiation threat, thanks to its magnetosphere discovered by the Galileo spacecraft. Despite being a moon, Ganymede boasts a robust magnetic field, usually associated with planets, and exceeds even Mercury in size. Galileo's exploration also revealed an underground ocean on Ganymede. These oceans could have formed under different conditions and may host various life forms, including bacteria and larger organisms like radiolarians and Artemia. Among Ganymede, Io, and Europa, these moons represent isolated environments where primitive extraterrestrial life could thrive, presenting challenges that colonists must overcome. However, there exists a unique celestial body in our solar system where these challenges become unnecessary, making it an exceptional candidate for exploration. Saturn, often thought of as a cold and gloomy world, surprisingly emerges as a prime candidate for potential life within our solar system. Previous missions like Pioneer 11 and Voyager couldn't reveal much about Saturn due to its thick cloud cover. However, the Huygens probe, landing on Saturn's largest moon, Titan, in 2005, unveiled remarkable findings. Titan boasts a dense atmosphere primarily composed of nitrogen, offering protection from cosmic radiation akin to Earth. Despite these similarities, Titan differs significantly from our planet. Its surface remains concealed beneath an upper layer of hydrocarbon smog, resulting in perpetual darkness due to faint sunlight. Nevertheless, Titan's atmosphere displays dynamic activity, with swirling winds transporting warm air from pole to pole, shaping dunes in its equatorial regions composed of hydrocarbon grains resembling coffee grounds. Titan's landscape consists of ice blocks, nearly as solid as rocks at frigid temperatures of around -180 degrees Celsius. Unlike many other moons of gas giants, Titan houses a subsurface ocean approximately 80 kilometers deep. This environment could potentially support extreme bacteria similar to those on Earth, although alternative hypotheses suggest unique forms of extraterrestrial life. Notably, Titan features rivers and seas of ethane and methane remaining in liquid form under extreme cold conditions. In 2020, scientists discovered cycloprophenylidene, a carbon-based molecule in Titan's atmosphere, a surprising finding given that such compounds are typically found in interstellar dust clouds. Titan's atmosphere is considered too warm for cycloprophenylidene to persist, raising questions about its source. The presence of this compound hints at the possibility of extraterrestrial life, since similar molecules are vital components of DNA and RNA. However, for life to thrive on Titan, it must find an alternative to water for cellular metabolism. Possibly, analogues of Earth's ice worms adapted to Titan's low gravity may exist, potentially larger in size. Nonetheless, the idea of riding them as seen in the movie Dune remains far-fetched. In the near future, NASA's Dragonfly mission, scheduled for 2027, will offer more insights into the potential for life on Titan. The mission involves a quadcopter capable of prolonged surface flight, anomaly investigation, and on-site study. Titan, often perceived as a cold and forbidding celestial body, actually emerges as an enticing candidate for colonization, potentially surpassing Mars in several critical aspects. The key reasons include the availability of abundant liquid and solid hydrocarbons that can serve as versatile building materials, in contrast to Mars's limited soil and rock resources. Titan's atmosphere contains essential fertilizers like nitrogen, methane, and ammonia, facilitating agriculture in specialized greenhouses, while Mars would require importing fertilizers, posing logistical challenges. The main challenge on Titan would be providing warmth, but it offers advantages such as a closer water source, the potential for hydroelectric power from hydrocarbon rivers, and a safer environment regarding combustion risks due to the lack of oxygen in its atmosphere. Titan presents a unique set of advantages for colonization, including ample building materials, natural fertilizers, accessible water, safer energy options, and a relatively hospitable environment contingent on effective insulation and safety measures. What's even more fascinating is the opportunity Titan presents for achieving the age-old human dream of unaided flight. It's a realm where one can glide through the skies like a bird with a simple pair of foldable wings, courtesy of its remarkably low gravity, just 14% of Earth's. However, despite these alluring advantages, Mars maintains an edge over Titan in terms of accessibility. The journey to the red planet takes less than a year, whereas reaching Saturn's orbit demands a minimum of 5 years. Both Earth and Mars confront inevitable challenges, with the sun's escalating heat over billions of years rendering Earth uninhabitable.